Hello everyone, my name is TM Apurva Sharma and I am pursuing engineering from Sri Venkateswara College of Engineering and in the department Computer Science from the section Bhaskara. Today the topic of my video assignment is pointeralizing. Before going into pointeralizing, we are going to discuss the basics about embedded systems. What is an embedded system? An embedded system is a computer system, a combination of a computer processor, computer memory, and input or output peripheral devices that has a dedicated function with a larger mechanical or electronic system. Uh, the embedded system contains electronic hardware and mechanical parts as well. An embedded system typically controls physical operations of the machine that it is embedded within. It often has real-time computing constraints. Embedded systems control many devices uh, embedded, which are embedded as part of a complete device, often including electrical or common use. Embedded systems range from those low in complexity with a single microcontroller chip to very high with multiple units, peripherals, and networks, which may reside in equipment racks or across large geographical areas connected via long distance communications lines. Applications of embedded systems. Embedded systems are used in wide ranges like industrial machines, automobiles, medical equipments, cameras, household applications, airplanes, vending machines, and toys, as well as in the most obvious cellulars and PDAs, the embedded systems are used. Now, pointeralizing. Pointeralizing refers to a situation in programming where two or more pointers can access the same memory location. In other words, aliasing occurs when multiple pointers of different type or the same type are used to refer to the same memory location or object. Pointer aliasing can have both intended and unintended consequences. When used intentionally, aliasing allows different parts of a program to access and manipulate the same data through different pointers. This can be useful for sharing data between different functions or modules in a program. Description. If a function has two pointers, PA and PB, with the same value, we say that the pointers alias each other. This introduces constraints on the order of instruction execution. If two write accesses that alias occur in program order, they must happen in the same order on the processor and cannot be reordered. This is also the case for a write followed by a read or a read followed by a write. Two read accesses to alias are safe to reorder because any pointer could alias any other pointer in C. The compiler must assume that memory regions accessed through these pointers can overlap, which prevents many possible optimizations. C++ enables more optimizations as pointer arguments will not be treated as possible allies if they point to different types. Pointer aliasing can have both intended and unintended consequences depending on the programming content. Types of pointer aliasing. Intended pointer aliasing and unintended pointer aliasing are the two types of pointer aliasing. Uh, Intended pointer aliasing. Sometimes programmers intentionally use pointer aliasing to create an alternative way to access or manipulate data. For example, in low-level programming, for example, aliasing can be used to improve code efficiency or provide alternative views of the same data. However, it requires careful management and understanding of the code to avoid unintended side effects. Unintended aliasing. In most cases, unintended aliasing can lead to issues that are hard to detect and debug when multiple pointers alias the same data. Modifying one pointer's value can be inadvertently affect the other pointers and their subsequent usage. This situation can introduce bugs, logical errors, and unexpected behavior in the program. Aliasing can make code more challenging to reason about, especially in larger code bases or when optimizations are involved. Disadvantages of pointer aliasing. Unintended pointer aliasing can lead to problems. It can cause unexpected behavior bugs, and make code optimization challenging for compilers. When a compiler encounters pointer aliasing, it needs to ensure that changes made through one pointer are visible to the other pointers that alias the same memory location. Failures to handle aliasing correctly can result in incorrect program behavior or produce incorrect optimization results. To mitigate the issues caused by unintended pointer aliasing, programmers often use techniques such as restricting pointer access, using type qualifiers like const and volatile, or employing compiler-specific directives or fragments to provide additional information to the compiler. Advantages of pointer aliasing. There are many advantages of pointer aliasing. Some are memory efficiency, data sharing and intercommunication, optimization opportunities, flexibility and versatility, performance improvements. Memory efficiency. Pointer aliasing allows multiple pointers to refer to the same memory location. Data sharing and intercommunication. Aliased pointers enable different parts of a program or different functions to share data and communicate with each other more easily. Optimization opportunities. Compiler optimization can be applied more effectively when pointer aliasing is allowed. Flexibility and versatility. Pointer aliasing can provide more flexibility in certain programming scenarios. Performance improvements. In some cases, pointer aliasing can lead to performance improvements as well. Now, example of pointer aliasing. Here we have considered a small code where to learn more about pointer aliasing. Here we are going to initialize two pointers, ptr1 and ptr2, and a location I. So here we are given ptr1 plus is equals to pointer I, and ptr2 plus is equals to pointer I. Here the two pointers are given the access to the same location I. The pointers could possibly refer to the same memory location, and this causes the compiler to generate code that is less efficient. In this example, it must read the value I from the memory twice, once for each add, as it cannot be certain that changing the value of ptr1 does not also change the value of the I pointer, which can cause changes in the value of the pointer 2 as well. Conclusion. Understanding and managing pointer aliasing is particularly important in embedded system programming, where memory constraints and performance optimizations are critical factors. In conclusion, pointer aliasing is a critical concept in programming that refers to multiple pointers accessing or referring to the same memory location. It can lead to both unintended and intended consequences depending on how it's used. That's it for the topic pointer aliasing. Thank you.